We're in. We're back. What were we doing? What were we doing? We had this, we had this, we had this, and then when we put a train, it would go up, and then it'd get confused. Connection equals, get the next rail piece. Yeah, I thought that maybe a cell, when we make a cell, instead of this, I mean, maybe we can have a standard, we can have an array of vector 2's called connection positions, but it can only have 2. So this is the actual world position connections, and we have this thing called set connection points. Cell connection positions Is that what we want? Connection positions are 0 equals cell. This is where we're doing this stuff over again. Cell world position. Get closest connection point. Okay. Inline vector 2 get cell connection point. Boom. So then we can go equals get cell connection point north. Oh, we need the cell. Oh, whoops, my bad, I got confused, easily confused. Top left. Yep. So now we had this debug where we were drawing the rails. Where were we drawing the is it in the grid? We're drawing here cell connection points test 0. Okay. Are they going to be zeros? 0, 0. we need 2 of these. So initializing the arrays to 0, 0, or maybe we initialize them to -1. -1, so they're not set. And then in here we can say if cell connection positions 0 is not anything, draw the cell at the thing and draw get cell connection point identifier not found. Oh, that's because this needs to be above it. Oh, need a chicken? Need a chicken? How do I get back to me? My streamage. Oh yeah. Alright. We're cool. We're Gucci. We're back. We're building. So boom. So it drew one but not the other. So it's drawing the grid first, which makes sense. Ten. So it's drawing it there but not there. When we go rail.h connection point, get cell connection point, north wall position half and thing, east cell size over 2, south cell size over 2 and cell size. So let's just do this. Alright, doggies. Okay. I know you're having fun, but so the cell and the rail type is vertical. Connection points set north and south. Connection positions. So connection positions they look pretty good. So there definitely are 2 of them. And then we'll fast forward to here. Connection positions. Oh, they are -1. Is this another thing to do with like? No, it is a thing. Rail.h. So what happened? So rerun that. Oh, yep. We created it. Set connection points. We did that, and then the cell connection positions look good. And then when we come in here, cell rail type -1 0 0. So if cell, oh yeah, that should be right. We continue. Connection position cell connection positions. Yeah. Maybe we will not draw this in grid because we'll draw it after we draw the rails. draw the rails, draw the UI buttons. We can do it here. Okay, thank you. Yeah, that's good. Oh, it seems worky. P. Oh, it's only drawing them. Get cell at world position. Oh yeah, that's kind of cool. So we've got this little debug going to show the connection points. And I guess we could have dun 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 dun. What are you heading to there, sir? Error, get next destination point. So that was in get next destination point. So we probably don't need this rail piece. Here. So we've got the cell, which should be train saying get next destination point. We don't need this. We just want to say rail type rail piece equals cell rail piece. Simplify this. Trains. We don't need this. Oh, what happened? Get next cell. So this is current cell. Well, again, we don't need this because we can just say rail type rail type rail piece equals cell rail piece. Oh yeah, let's go to the definition, get rid of this. Get next destination point, we just need the cell and this. We don't need this. And this connection point stuff is a little weird because we're doing this weird distance-based connection points. So it's trying to go down. It's going down. That kind of worked. But not really. Let's do a little debug drawing. Get rid of this bit set drawing because we're not really using this. Let's draw circle V of the train dot target position, and we'll make a green circle of 5. This might illuminate us a bit. It's trying to get to there. That looks good. Now it's trying to get to there. That looks good. Now it doesn't know what to do. Okay, what we want to do is get next destination point, incoming point. Oh yeah, well this is kind of doing all that for us. It's a little confusing, but we could just say the cell rail type, depending on what type it is. But get next cell. Let's also, on trains, we will rectangle, let's go grid cell pointer cell equals train get grid 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 dot cells rectangle is cell well position and grid cell size, rectangle EX train current cell, and we'll go fade yellow 0.5 F. So this is the current cell debug, and this is the next cell debug, grid cell. This is where we're headed. We're drawing lines. It all looks good until something crazy like this happens. That works. That works. Okay, that one's backwards. I love the debug. Draw rectangle EX, draw rectangle rec pro rec rectangle and color. This might be another thing where things are the wrong way round. Boom. Okay. Is it on get next cell? Well, it's connection point. Get connection point. Route.cpp. Get next cell. Okay. Who calls this? This is an actual cell. And that's an actual cell, is it? We got pointers. We do, we got pointers. Okay, let's debug router.cpp. Get next cell. Incoming point. So if we're coming from the north and it's a vertical one, we want +1. Yeah? And if the rail piece is top to left, we're coming from the north, we want x -1. So we're coming from the north. This is our current cell, and the next cell is this. Top to left, x minus 1, y plus 1. And then top to right is x plus 1, y plus 1. Let's see that in action. So this should be testing vertical into this. Yes. Yes. No. So we don't need to do the plus 1s on the y. Yes, and then if we put one there, no. Okay, so top to right, plus 1. Okay, horizontal, we're coming in from the east, x minus 1. Coming top to right. This one here, and we're coming in from here. So the next one is y minus 1. Bottom to right, plus 1. So I got confused. Vertical south. Coming in from the south is a vertical line. Coming in x, y minus 1 and x. Bottom to right, plus, minus. Coming from the west, horizontal, plus. Bottom to left, coming from the west, y plus, y minus. So this, we'll test this loop first. Let's see if we loop up. Boom, boom. Oh, why that? So we're coming from the south on a vertical. It's x and y minus 1. That's what gets me confused. Because I feel like that's what it is. And it doesn't, incoming point is being miscalculated there. So trains getting the incoming point. Connection point is rail world to connection. It's this thing, I didn't write this thing. Let's whoa. Closest point equals get closest connection point. Closest point at x. This seems crazy. But it was just like, yeah, that's it. Is it though? See, that doesn't work at all. So, I think vector 2 closest point, yeah. And then if closest point dot x so this is the first connection point in the cell array, and then we want to say if cell rail type equals vertical. So how do we know? We still want to verify. I think we want to do vector to if closest point equals north point is what? We don't have a operator for, do we have vector to equal? There is no vector to equal. Is it in RayMath? I think I'll put it in here so it doesn't have a vector to equal. If closest, I could probably overload this. Hello. X, yeah. Write it out for me, bud. Oh, no, we don't want the closest point, we want the other point. Oh yeah, no, we do. I don't know if this is good. How's your day going? Okay, that seemed to work better. Oh! The trains are going. Oh, we're doing it. Oh, we're making visualizers. These enemies I'm working on are causing... Ah, enemies! Enemies are your enemy. Oh, that one decided to go that way. Interesting. Do we have train movement? We need to calculate, we need to learn Bézier's. But essentially the logic for following the track seems to work.
We're not too sure exactly how we're going to do it, but it's going to happen.
Trains. Do you ever make systems and like you purposefully keep them a little unhinged with nothing to stop you from just like this, like making more and more and more and more? Or do you like to do things the safe way and put like limits on everything? Hard fought battle, but the trains are moving. Yes, indeed. Indeed. Especially while developing. Yeah. I got this theory that like debugging, stuff like this, informs games sometimes. It's like sometimes you want to put a thing in to be able to see what's going on, and then when you see it, you're like, that's kind of cool. That should be a part of the game. I feel like debug's almost more interesting than the game sometimes.
Sometimes we just do it, and then see what happens.
For the sake of, this is the first time that anything's actually worked. May as well enjoy it. And be able to drag would be cool, and remove. But oh, interesting how it does that. How does it know which way to go? Beep 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 beep. Yeah. Well, that's kind of cool. And then maybe there's some sort of the game is something about, I do like the idea of connecting little stations and then making some, you just keep on building and upgrading the network, keep on building and building until you like map out this thing that's just running with tons of little dooders going back and forth. Maybe they're not even trains. Like I quite like this, that they're sharing tracks and stuff, because it is kind of limiting. You have one train on a track. Is there any sort of serious memory leaks going on? Ray Jam. Oh, I looked at that, like 300 megs. What's going on? 39 megs of RAM. Seems good. GPUs, it's all the streaming stuff that's doing it. Say this is running at a fair clip. Why though? Yeah. I wonder how easy it would be to do the parabola. Setting up a shipping network. Yeah, And then it could be like this, like overly simplified, but you've got little pink squares to connect to other pink squares, and then as they go, and they just, the goal is to make gazillions of dollars a second or something. I don't know. Or you just keep building and building in freeform and try and just make the wildest networks until you're building like something visually quite cool to look at. I like that in mini metros. This is a cool song. Get all these big ideas. So things to do before we get onto the next big thing. I had an idea of like a quick thing to do might be able to mouse scroll through the different things. I think that a cool thing would be to get the trains to do a little Bezier curve. Yeah, lots of options. And be able to do this. This would be pretty cool if I could put this down. Again, that's going to mess up our whole thing. The maths. So what do we want to do here? So essentially the train is just right now it's just adding to the world position. But if we were to do some sort of lerp situation, so this is thing, direction, and this is rotation. The rotation is fine. Now, this is beyond me to do, but I'm gonna ask my good friend and say, hey dog. My train is moving along a curved track on corners. Is there a way to calculate a movement along the curve like Bezier or something? Sure, no problem. Here's a curve movement. Bezier quadratic. Oh, of course. P1. Calculate the next position on the Bezier float T. Vector 2 distance. Update the train position. So it's not too bad. It's just adding this Bezier quadratic. Does raylib have raylib.h? Does raylib or raymath have curve? No. Bezier curve. Let's just try putting it in engine.h. There's a good place for it. Maybe we'll make a file. Add a new item, header file, and we'll just call it curves, man, curves. Include engine, namespace. Oh, do we need curve? Let's just have this to Bezier quadratic. Vector 2, what is it, P0. I could copy paste this, but trying to learn something. P1 on vector2 P2 float t. Okay, totally different. Float u equals 1 over t 0.0 f minus t. Float tt equals t times t. Float uu equals, look at this, man. Why would you? Vector2 point. Okay, point dot x equals uu times p0 dot x plus 2 times u times t times p1 dot x plus tt times p2 dot x. This is the kind of thing that people would use like libraries for this kind of thing, and fair enough, because I'm looking at this going, so I kind of like to use ChatGPT this way. I mean, sorry, GitHub Copilot. At least I can kind of, I mean, sometimes it doesn't give you good code, but. Oh, so we've got to also calculate midpoint, simple midpoint. Let's also make that vector2 midpoint. To AB, a dot x plus p dot x over 2, b dot x, yeah. So trains, let's go vector2 p0 equals train position. So we don't actually need these. We can just say vector2 p1 equals midpoint. Oh, we need to include curves.h. Make them all in the core and then in order. Midpoint of train.world position and train.target position. Float t equals train.speed times get frame time over vector2 distance, world position, train target position. So this is how far along the curve we are, I imagine. To next position equals Bezier quadratic. Vector to next position equals, maybe I'll call this midpoint. So next position and then update, then we're just straight doing it. That was the old one. Train.world position equals next position. Just like that. It's going to work. And maybe, ooh, okay. Yeah, I think I know what the problem might be. We can't include engine in here, but we can include raylib. True or false? False. Is it because raylib's included as well? What if I just put these in engine? Will this work? What's the problem? Oh, we definitely don't want to. Okay, don't include that. Now everything doesn't work. Did I leave off a thing or something? What happened? inline, inline. So what is the actual problem here? Vector, engine, does engine, oh, because there's no vector? Let's just include vector here. That's where we need like pre-compiled headers. Whoa, vector is not a member of standard. What happened? Why are you so angry with me? Raylib, ray math, does definitions have something weird? No. Vector 2 int hash comparator. What even happened? Oh, midpoint Bezier quadratic. Let's go back and see what I actually did to make it so angry. Oh, was it the reorganizing of this stuff? Was it just it didn't like that? Oh, no, it doesn't like me doing that either. This is the thing I hate about C++. It's all this order of includes and stuff. What do you want me to do? Okay. Sorry, we won't include curves. We'll go back here. Raylib is not a word, thanks. But in trains, we will include H. Build. Nice. So will this quadraticus no, does nothing. That's what happens when you don't know. Will this so the 2 points in question say the east and south points of the cell. Oh, maybe we need to pass it the cell dot center. Maybe we'll pass the center of the cell. Midpoint. Let's put the center of the cell. Train dot current cell world position. Vector 2 train and cell size over 2 and cell size over 2.0f. It's as simple as that. That's the midpoint. Whoops. It's always moving towards the midpoint. doesn't as expected. I tried adding the center of the cell as the midpoint, but what we really need is some linear interpolation, but on a curve. Yo. Whoa. This has got much more. Now we've got more points. A bigger Bezier function. Bezier cubic. Yeah, we need more Bezier. We need more Bezier, of course. So I'm going to copy paste this. And give it a hoon, see what happens. I did watch the Bezier curves thing that Freya. I did. Yeah, see, this just moves into the middle. What? Okay. Now I'm in ChatGPT loop where I'm just going, what is it doing? This just, am I not following instructions properly? Position equals next position. Then the direction, then da da da. The train moves to the center of the cell, then slows and stops. This is not how to not do it. Oh my gosh. I'm squarely in the I don't know what you're doing anymore. So define control points P1 and P3. P1 and P2 are the train next cell, what would it be? Increment progress. Okay. So we're taking out the speed thing. Oh, we're not using train speed anymore, though. Oh, you like add a progress thing. Add this line. I feel like this is just an unhinged person. Just like, yeah, nah, honestly, man, just add this progress line, you'll be right. Yeah, I don't have a T value anymore, sir. Oh, we don't have this. Train.progress. Yeah, sorry, I got myself into a little spiral of ChatGPT, stopped thinking about it myself. Yeah, things is totally broken. Things are not working at all. Back. Listen to chat for ChatGPT. Let's get rid of this progress thing because this seems strange. I feel like your first parameter to be the entry port, not the current location. This one. Yes, that. No, current cell world position. Well, that's the top left corner. That's never right. Oh man. Yeah. But yeah, I've been making those vids and it's slowly starting to catch on, which is kind of cool. Don't know how this one's going to turn out. Oh, sleeping doggies. The only problem is I don't actually know the entry point. We don't store it. Maybe we probably should. Yeah. Vector to entry position. That should be easy enough to store somewhere. When we do this thing here. Train.entry position equals rail don't we have a thing for this? We already make this get closest connection point. Cell train world position. I mean, it is exactly that. This is for the first entry, so we could just make it train.world position. But then when we figure out what the next one is, train world position and train dot entry position equals train dot target position. Yeah, train dot, let's just do it like this for the sake of clarity. Train dot entry position. Vector to add, oh no, yeah, this is the midpoint of the cell. My bad. But this, yeah, this is what you're talking about. Train dot entry position. Does this do anything? Yeah, you're right. Train speed, blah blah. Can't we just use and interpolate? How does it work again? I think it's more complicated than I think. You have point A, point B, and then you need like point C, and then don't you like, it's like an interpolation between all those? It's 1, 2, yeah, and then you get the midpoint, and you interpolate between that and interpolate between that, and then do some calculation. You load up a library. Midpoint, that's always going to be train target position, and T, I feel like this should also be entry point, entry position. Is that a bit of T? Ah! Maybe we train speed times frame time over vector 2 distance between. Can't we just have something simple? Or is that as simple as it gets? Can't we do a vector 2 lit or something? I'm sure it's like float t equals vector 2 lit between the train dot entry position and the train dot target position. Oh no, that's gonna send me back a vector. vector to lerp and we want train dot. Fuck. Nah, I knew this was. I'm sure this has become overcomplicated. Do me a new one, sir. Okay, let's try again. We have an entry point to a cell, say west, and an exit point, say north. And we want to move our train along the track, but curving using the midpoint as, what do you call them? They put it in here, didn't they? As control point. Oh no, it loves to like do init window and all this stuff. This is just straight. Just make it T. Look at that. That's so simple. Surely. I don't believe it. So saying, yeah, get the midpoint, but the midpoint is just the midpoint. That's not the midpoint of the actual cell. The midpoint will just be in between the 2 points, meaning no curve. Now we're arguing. You're correct. Oh yeah, it loves to do this. I'm gonna write out your whole file now. Midpoint, yeah, midpoint, but midpoint needs to be, doesn't midpoint need to be in the center of the cell? Cell center, yeah. We did that over here, right? Midpoint equals vector to add, and then the direction, the perpendicular. Now it's normalizing perpendiculars, offsetting. Now it's doing all sorts of madness. I feel like I need to figure this out for myself. I'll try one more of these. Whoops. Let's just get everything from here to there. Why is there a perpendicular equals normalized perpendicular? Oh, I feel like this is just bad programming. We have errors. Where's the error? Vector to direction. Oh yeah. Yeah, that just straight up doesn't work. We need to close you down. Cell center directed is subtract from the target position and train entry position. Are we setting this entry position right? I think we are. Entry position equals change world position. Target position is a get next destination. We can do one more debug where we draw. We don't need to do this right now. Oh, I hate this type of comment. Let's draw circle train entry point. I'll make it yellow. I feel like we've already got these debugs going on. Yeah, so it knows what the entry point is. But this crappy stuff here is no good. Calculate the cell center. The direction is the subtraction between the target entry position. Perpendicular equals that. Offset equals 50. Control point equals vector 2 add cell center, vector 2 scale perpendicular and offset. Let's save this in the train as well. Control point. Trains. Train dot control point equals control point. And then draw the control point in magenta. Not red. Magenta, sir. Oh. Yeah, see that doesn't seem right. Should be in there. Okay, so this is saying this value here changes the control point curvature. That seems better. 1. What is 1? That's where we want it to be. And then the control point equals vector 2 add train dot speed times vector 2 distance. I don't know about this line. Times delta over the distance. Next position equals Bezier quadratic. Entry position control point target position t. Let's just see if we're getting a good t value. T. Just like that. Train t. It's changing. There's a page down but no page up on this thing. Next position. So this Bezier quadratic. Did I write this wrong? Did I just copy paste this? Where's the original? Does this look okay? So why give me nothing? Let me just see again those values. We're getting nothing printed. Did I comment that out? I did. These seem like weird values. What what is the desired range of T? Yeah. T values don't look good. I don't know whether this is the answer, sir. Whoa, why would train T be so not? Even after clamping? Does this have to be? Oh, now it looks better, but T equals 0 means entry point. Yeah, that's what I thought it should be, but these not. This is like trying to do like alert using distance. I think this is all bad. I think this is a bad line. Train speed over train max speed, no. Float distance equals distance from there. T equals train speed over distance? No. The values of T are not good. I think we are interpolating poorly. Current travel time plus equals frame time. T equals travel time over train travel time. So how do we figure out distance over train max speed? This is overly complicated, dog. I thought there would be a simpler way. I hate following it when it doesn't feel good and you kind of go floats, travel time, float, total time to travel, but it's changing because it's under, maybe when a train enters a cell you could record when it enters how long it should take to traverse. Yeah, that's what it's trying to say. But then I'm like, but the train is changing speed based on its acceleration potentially, so that should change across where it is. Maybe we need to normalize distance. This all this stuff's fine. Oh, whoops. This stuff's fine. But vector 2 distance equals target position. What's this thing called? Entry point. Entry position. No, not subtract, sorry. and that's going to be a entry position to target position. This is actually a float. And then train speed over distance. Doesn't seem right. Oh, are we no longer doing a... Oh, we are. Does this give us anything better? Kinda. Oh, wow. That moved along a curve. No. Now not so good. There was a curvature. I saw a curvature. It just keeps going back and forth. Oh, and then, yeah. Maybe we just need... Yeah, upon entry to store, float, distance to next. Distance to next cell. Go away, you. We're going to figure this out on our own. And maybe we have a inline... We're not even using any of this anymore. Inline void, inline float, get distance. Let's just say inline void into cell, train cell. That seems bad. It's this stuff. Train.current cell. I feel like we just have to do it in two places. Train dot distance to next cell equals vector to distance. Train world position and train target position. All this stuff needs to be sort of nicely encapsulated into a thingamajig. Train dot distance to next cell. And then, yeah, essentially what you're saying. The train float distance traveled. We're going back to what it was telling us to do. But distance traveled equals 0. Yeah, and then so now we need to update the distance traveled. Distance traveled plus equals thing. Float t equals the entire thing. That seems easy enough. That seems easy enough. Kind of what everyone was saying except me. Okay. We curving. It seems to go faster on the curves. I quite like it. This also doesn't quite look in the right direction, because the direction is calculated by this perpendicular nonsense. Maybe we want to atan from the perpendicular dot x. It's Frankenstein. Everyone's adding something. Wow, that's not right. Yeah, that's totally not right. Atan to direction is vector to subtract. I think it's train target position and entry position. No, I mean, that's probably all right for this, but not for rotation. I think vector 2 facing direction equals kind of needs to be can we just do vector 2 scale next position times 10 or something? Or is this not going to be right? Goes faster around the curves because the distance is based on a straight line, but the curve is longer. Indeed. Facing direction. That ain't it either. Equals vector to subtract. It's so close. Next position. Let's do this up here. World. And then it's very minor. Maybe that's enough. Who would have thought this stuff's actually difficult? Whoa, it kind of... I like how it does that. That's funny. Why the... All right. Yeah. It doesn't... Oh, because also when it's going around a curve, it's got less distance to travel, right? The curve is actually shorter because it's only going from there to there, whereas this one's got to go for twice the thing. Maybe there should just be a thing that says the distance traveled on a curve is twice. But that might not feel right either. Let's do want to... Oh, we're out of juice again. How does this keyboard, man, it's a nice keyboard, but it dies like twice a day. It may be because it's on wireless, you know, not Bluetooth. Facing direction equals facing direction is 100. So we're just gonna scale it out so it doesn't have wonk. Could still have wonk. It's still gonna kind of cool. This facing direction. I don't know. Distance to next cell equals distance. Let's just say if cell rail type equals does not equal vertical, and cell rail type does not equal rail type horizontal. See what happens if we train dot distance to next cell times equals 1.5. Seems super slow. It was speeding up. The little artifact cracks me up actually. We'll make it race cars. So, that doesn't feel super smooth. But it's kind of alright. What if we make the just crank it up? Yeah, I need that tool because making these is just too slow. Go buddies. With those little dots. Yeah, yeah. Just like these little trains. Love the debugs, man. Go trains. Perfect. Edited my, so I'm gonna head out. Good luck. Thank you. Thanks for coming and hanging out. Good luck with your stuff. Yeah, I'll be at this until, well, 7 days is up, but I'll be around. Streaming's fun. Nice to chat with you. All right. Might just make some trains. for the lols, and then make a cup of tea. Oh, that's gonna... So the theme of the game jam is connections. So I've got to connect something to something. This could have more trains on it. Are they even trains at this point? They're more like little cars. What's the game going to be about? It's what we're kind of... Originally we were doing a sort of miniature transport tycoon, and we started out with the classic transport tycoon tracks, but then it got too difficult, so I simplified it with these more basic tracks. So the game jams, yeah, it was going to be connections. So I was thinking of making little squares, like a purple square with a pink square, and you've got to take stuff from the purple square to the pink square, and you get resources each time. So you make a little thing, and then you got to connect up all the different things and create a network of things. My partner had an idea for to puzzleize it a little bit, puzzleify it a bit, where you had entry points and exit points, and you had to set the trains so that they hit the exit points in the correct order, so the train tracks have to be different lengths, which is a kind of a cool idea. And maybe they go different speeds based on what color they are, so you have to sort of time them out. But essentially, I'm not sure. I mean, it's been 1.5 days just getting the trains to move around. So I'm thinking of what's fun but not super ambitious. It's day 2 today. There's 7 days in the game jam, and it'll be cool to get things a little bit. I mean, I love these kind of basic shape things. They're really cool. But to add some sort of verve to it. Oh, that's cool. That little connection point's not always the same. Control points move around. Might just go make a cup of tea and be right back. Dog pee break, not dog pee break. We're having a coffee break. I guess we can make tea. Yeah. Want to try and get by on visual appeal as much as possible. Because how do you even make a game? How do you make a game in a week, let alone make a game in C++ with raylib in a week? Whoa! I shook them out of the screen. Robust. Maybe what if they're like tubes of marbles of different colors and you're trying to sort them or something? Or colors. I was working on a game about matching colors, but this doesn't really feed into the connections thing. That was funny. I think maybe this visualizer is so wild. Is this thing live? Is this thing on? Go live, doggy. This visualizer is insane. So yeah, in the square there's like one of these and one of these, and they're just placed around, but they're different colors. They're like over here and over here. Is this very gamish though? And then you make tracks. So you want to go down to this one. To get to this one, you got to go around this one. And then you're like, oh no, how do I get over this one? Oh, you got a bridge. But this thing's called Concepts. It's like, I actually had it on an iPad. I got it on my iPad. I thought it was pretty cool with the pen to do notes and to do like sketch out ideas of like systems and stuff. And then I just found it's on Windows, on the apps, the Windows, what is it, the Windows App Store or whatever it's called. And it's kind of cool because it's got a pretty good zoom range and kind of goes on endlessly. But my favorite thing is the snap to grid thing. So you can do your bits. And then it's got like it's got these this color pick is kind of cool. And guide. Whoa, the guide. I don't know. It probably doesn't. These are the types of curves we were talking about. It probably is way more powerful than what I use it for, but I just tend to doodle in it. It's called Concepts. I just think like, how is this challenging other than each one gives you resources or something? Green resources you can use for tracks, pink resources you can use for trains, orange resources you can use for something, or they will just give you money. Like a transport tycoon, you get the cha-chings. But what is the challenge other than track layouts? That could be kind of alright, I guess, if you could only make tracks with pink tokens. Where are the bright colors at, me? There they go. Track. I can hear my dogs in the background. It sounds like a squeaky faucet. Track, train. Then what do? You just build up track tokens to build more tracks, and then you need train tokens, so you got to build trains, and then you need more track tokens to build more tracks, and then you need more train tokens to build more trains. And then the goal is to get some amount per second. Doesn't sound great. And the full transport tycoon thing is a lot of logic going on about industries and all this sort of stuff. I already learned just how complicated these type of train tracks are to implement, and all the possibilities and logic you need. It could be something like lemmings, like there's a number of things in here to get, like, is there a brush tool? What's the tool called if it's, whoa. Dynamic pen. So there's like, whoa, that's not the one, this one. So there's like 2,000 of these. And you need to connect it up, and then it goes 1, 2, 3, 4, and you got to empty the levels out. But then again, how is that fun? It could be fun. Maybe the number keeps going up, and you need to get the number to 0 by being faster than the increase of the number, where you just got to keep adding and adding and adding and adding. This is like 2,000. What if part of the challenge is that you have a limited number of pieces? Yes. Yeah, I definitely thought that maybe another one is bridges, because they can be another piece that's expensive. Maybe you've got a time. Maybe there's a time limit. And there's a number of things to mine out of here, and each time a little car goes there, picks up one, bloop, and deposits it in your bank. And then you got a time limit to get them all to 0, And you can use them to buy more tracks and trains and bridges and stuff. And a track might cost 20, and a train might cost 200, and the bridge might cost 2,000 or something, or 500. So you can only ever buy like however many. And then the goal is to clear these before the time limit. Excuse me, doggies. They're being chaotic over there. It's their time for their walk, really. So that way there is sort of a limit of how many pieces you can make based on how much you can earn. And you have to earn faster. So you could do it effectively slowly, but then you'd run out of time. You could put one thing on there and wait 2,000 iterations and it'd just take too long. So you have to keep adding more trains or little harvesters, whatever they're called, little dude. And these currencies, is this total currency? Does it matter? Where did you get that from? Huh? Where did you get that from? Hey, Biscuit. Where did you get this from? It's not yours. It's also kind of programmy-y a little bit because it's like values and what happens? Hey? 4 o'clock. What would be needed to make this happen? And that could be random as well, so each time's different. So we'd need mines or whatever they're called, and we need stations. And we need some sort of currencies. Question mark. Because, sorry, I'm talking a lot. But the idea, I mean, I'd like it to be like that thing when once you get it fully humming, you've got like a screen of things like little values going. Blah, 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 blah. So one thing that's cool about this type of programming is it's fast. It's super lightweight. We work in raylib, you know, you can manage gazillions of these little things and have little draw text every time you get +2 or whatever, +2. You want this just to be like this. Like you're building, it's kind of like Factorial or something, but way, way, way simplified and doable in 7 days. Is Lou still here? I feel like this is kind of doable. And you have to have the trains be able to go recognize when they're at a station. Hey babe, think this is a good do you think this is a good idea? Or should I just make the idea you said? You could have multiple routes. Maybe they go slower. Hey. Maybe they go slower if you get too many on one thing. And then I guess maybe you could also get scored on how much currency is left over. Oh yeah, sorry. The idea is this. Sorry if anyone else is listening to me harp on about this, but there are, say, 3 different colored mines or little squares, and each of them, oh sorry, these ones maybe, each of them start with like 2,000 things in them or whatever, however, a number of things, and then you've got drop-off points of the same color. So you build a track between the 2 things and you see little dudes going ding dong ding, picking them up, and the goal is to get them all to 0 before the time runs out. But you can use the things you pick up to buy new tracks, trains and bridges, which are different values, and then the idea is just to have this network of gazillions of these little things going brrrr, mining it up before the time runs out. And maybe you build multiple lines to make the trains go faster or something. So it's like, how quickly can you get it done? How much money do you have left over at the end? So how fast can you do it? And how efficiently can you do it? Well, look at that visualizer. Who's making this stuff, man? Sorry. I mean, yeah, we already agreed that just the little things moving around is quite fun. All right, that's it. We're doing it. This is my partner. She's working at the moment, listening in, and I'm distracting her with this crazy talk of this game jam stuff. Love that one as well. I think that could be a cool game. Could be overcomplicated. What are you doing? It's the dogs. Time to take the dogs out. Maybe take the dogs out, have a walk, have a think. Let's have a little hoon, see if anything comes to mind. Oh, maybe just, oh yeah, no, the dogs are getting restless. The dogs are restless. Let's make a thing that goes up like a pattern. Do 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 do. Let's make some patterns. The doggies. I guess there's some way to make it faster by adhering to less curves or something. Oh yeah, we need to manipulate the speed based on the curve or something. Oh, who's there, Mr. Biscuit? Probably fit a little. Tick 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 tick. Hello, Beansy. I know. I know. I know. You wanna go out for? You wanna go? You wanna go? I know. I know, Beansy. I know. Hey, Biscuit, did you want to come too? Come here, buddy boy. Come here and see the people. Yeah, maybe I need to take these dogs out. Have a little break. Might come back and do a little bit more. I feel like it was good that things actually got going today. Because at the beginning, mouse scroll to switch between. That's exactly right. That was the thing I wanted to do next. The mouse scroll switch. The dogs, they be restless. I wonder how much this could handle. So many, I believe. And you get these little snakes going. I need a frames per second counter, but raylib will just sneeze at this until I don't know, I can simulate thousands of entities in my other game with way more complex behaviors. Yeah, they're set to a max speed. Maybe that, and it can be turned off. Yeah, actually, it could be turned off. That brings up a good point though, because what if you're making your rail and they just keep accelerating. But once they get to the station, they got to slow down and stop. Well, look at that, man. It's crazy looking. These are raylibs just got draw shape. Calls, which I think under the hood it's just going in and creating a texture, like it's creating two triangles and it's creating a rect and sending it to OpenGL and then filling in the shapes. I mean, you can go read the raylib's all open source, so you can go read how it's being done. And then it batch all the shapes are being drawn from one texture, so they're they all get batched, and it's you can do like 8,000 in a draw call or something. So the actual drawing of all the shapes is very fast, and then the logic side of things, I mean, this is how much of my processor is using, is like 1% or something. You could convert them to images. Like the train tracks, these are images, these are... Oh, what is that? Oh, that's because I keep creating new things down there. Yeah, these are sprites that we made up in Pixel Composer and packed into this sprite sheet. So these are all drawing from one texture also, just with different source rectangles. So raylib's probably doing like 2 draw calls or something to draw the shapes, and then maybe 3 because it does a background, then the rail, then the shapes on top. Pretty cool, man. maybe you've got to do an inflow and an outflow. So they have to have a way in and a way out, and it has to be a loop. Besco, what on earth? How did you get up there, my friend? Come on, doggies. Should we go packies? Do you want to go packies? Say yes if you want to go packies. Speak. Yeah? Yeah, you look pretty excited. Yeah, alright. Time to take these dogs out. See how we go after. It might come back on. Oh yeah, and then you shake it and they will go off track and then they're broken. Yeah, raylib is great, man. This whole way of, I mean, it's this weird paradigm where you're like, both don't have an engine, so you feel like you have to do everything yourself. But then you're like, doing everything yourself is kind of fun. Depends what your goals are, I guess. Okay, Beansy, we'll go. Okay, we're gonna go. Okay, I gotta go to park. Okay, dogs demand it. If I'm not back on later, whatever time, wherever you're at, in the next couple of hours, then I'll be on tomorrow Australia time. But thanks to everyone for chatting and hanging out in general. Much appreciated. Hopefully this thing turns into something within 7-day limmies. I know, Beansy, we go Parkies right now. We go. Okay. All right. Cheers, everyone.